I had you all write down some things that you still need help with, and we're going to go over those things today. But one of the comments was make sure that I get the videotape of the solutions of the quiz. So I think, I talked to Ben, it looks like we probably have been doing it, maybe not, but he's going to make sure that he videotapes the solutions of the quiz before we start the lecture. Okay, so this is all the information on setting up and what I want to see, and you'll see that on the exam too. So really the only question is here. So Charlie, what's the first thing we do on these problems?
Find a given.
Given. So is there anything in the words of the problem that aren't in the picture?
No.
No, so you write the sketch. Okay, next. Gonzalo, what do we do?
Find.
Find. So what do they want us to find?
Reactions at A.
Okay, all the reactions at A. So we could write reactions at A, or we could actually write down what those reactions are. So Hector, let's take a look at A. What's going on there? What kind of support is that?
The fixed support.
Yeah, fixed support. And what could a fixed support resist? So remember, even if you can't remember, when you see the picture, if you don't know what kind of support it is, you look at the two things that it's connecting. It's connecting the wall to the bar, and you can see there are screws there. It's held in. So what do? How do I determine the reactions of the supports? I take those two things, right? Is it 2D or 3D? 2D or 3D?
3D.
3D. So can it move in the X?
No.
Y?
No.
Z?
No.
Moment in the
No.
X. Moment in the Y.
No.
Moment in
No.
the Z. Okay. So Gonzalo? No. Hector. So what reactions are at that support? Hang on, Charlie.
So is it AX, AY, and AZ?
Right? AX, AY, AZ, and then anything else. Is this connection here, the wall to the bar, resisting rotation around those axes?
Yeah, around AX.
Yeah. And now, I always draw things positive. Do everybody draw things positive or negative or? Okay, and you have to remember that you have to make sure that you're drawing it so it looks like it's positive, right? So you put your fingers in the direction of the x-axis and you're having it spin like this. Does that look positive? Maybe it's not a great circle, huh? How's that? That's probably better. Does it look positive?
Yeah.
Should this have been connected? Yes. Okay. How about Y? So it's coming around and rotating around here. So that's M-A-Y. And how about Z? Fingers go on the positive. It's coming around the back here. Moment A-Z. Okay? And you might say that it looks a little small. Draw your free body diagrams huge so you can see it. Because when you refer to the free body diagram during an exam and you're a little rushed, if everything's squished into a small spot, you might not be able to clearly see it. So draw it big so you can see it. So does AX, AY, and AZ look fine? Do the moments, take a look at the moments. Do they all look like I drew them positive? Okay? All right. So instead of writing reactions at A, I could have just wrote AX, AY, AZ, moment about X, moment about Y, and moment about Z. Okay. And remember, all this is what? Scrap, right? I didn't draw my free body diagram yet. Okay, David, next. So what did you do next? You did given, find. What's the next thing you got to do?
Set up a table.
Set up our table. Forces and moments. You guys remember that in chapter 3, we only had forces in the column, but now we have forces and moments, magnitude and direction. Hey David, do you want to continue? Give me some forces or moments.
Force 1.
Okay, which one did you call force 1?
200 newtons.
Okay, so if I'm going to call it force 1 here, I better make sure that in my free body diagram, when I do draw it, I'm actually calling it force 1, or just call it 200. right? We don't need to introduce a variable. Variables are good when we don't have a number, right? But we have a number. So how about, can we not do that? David, is that all right? Let's just do 200. Don't put any variables in there if we don't need to. So magnitude,
We got.
direction.
We got.
Ivan, next one.
150?
Magnitude,
Yeah.
direction.
Yeah.
Mike?
AX, AY, and AZ,
AX, AY, AZ.
and
What do we know?
the directions.
Just the direction, how about the magnitude? Cameron, what else do we have?
What would they do to, about X, Y, and Z?
Off the page.
Do we know the magnitudes?
Nope.
What? Oh, thanks. Directions?
You know the record.
Hey Daniel, I know you just walked in, but I know you can determine. Tell me what the, how many unknowns are there? 6 unknowns. So how many equations do I need? And is it a 2D or 3D body? 3D. So how many equations can I get from a 3D body? How many equilibrium equations can I get from a 3D body?
Well, you can get the forces in the X, Y, and Z,
Yep.
and the moment in the X, Y.
So 6 total, right? So I can get 6 equations from one 3D body, so I only need to analyze one body. Eddie, what body do you want to analyze?
Body.
Yeah, which body do you want to analyze? Yeah, the whole part. Remember in chapter 3, way back, we usually just analyze the point. Why did we only just analyze a point in the chapter 3 problems?
Concurrent forces.
Because they were all concurrent forces. We looked at forces all coming together in a point because there's no rotational motion. Do I have to separate you guys? Okay, so one body. I'm not going to draw the free body diagram, but that's what you would do, right? What needs to be, okay, so I'm going to start answering some of the questions you had that you wrote on a piece of paper. What needs to be on a free body diagram? Daniel. Axes. Axes, right? Make sure you have axes on it. So which way is our axis here? This is X, and this is Y, and this is Z. What else needs to be on it, Stanley? Oh, I just, you guys got lucky. It was a distraction from you guys talking. What has to be on the free body diagram? All the magnitude of the forces. So I have to draw all the forces, right? So I'm going to draw the forces that I'm going to draw AX, AY, and AZ. I'm going to draw all the moments. I'm going to draw the 150, and I'm going to draw the 200, right? Okay. Not only do I have to draw the forces and the moments, but what else do I have to do about the forces? There are locations and there are directions. If there's an angle, if the force is going off on this way, and it's in a 2D problem, and a force is going off, you got to give me an angle, or you can give me the ratios. Okay, but you have to give me the direction. You have to give me either a variable or a magnitude, and you have to show a direction or an angle. Yeah.
Do we have to specify the distance from whatever point?
That's the next part. What's the next thing we have to do? Matt?
Specify the distances.
Yeah, when you use your free body diagram here to do some of the moments, you have to know the distances, right? So you have to. Is everybody listening? Because this is what people leave out on the free body diagrams. They forget to draw the distances. You got to make sure that you're drawing, what is this? There's a 2 and a 1. You have to make sure you get the distances, right? Okay? That's something people leave out a lot. Okay? All right. Now what do we need to do? Gabby, you went. Heather, what do you want to do next? So let's just check. We did the given and the find. We set up the table. We knew what the unknowns are. We figured out which free body diagram we wanted to draw. What's the next step? Yeah, and I'm going to put that other step in here. What do you think I'm putting in here? Components. In this problem, all the forces and moments were all in the x, y, and z. So you didn't have to break it up into components. But if I had some kind of cable in here, I'd have to break it up into components and then you can do your check. Okay. So then the next thing is, what did you say?
Figure out your equations.
Equations. And what equations do you want to do first? Okay, so I think we would all say that we prefer doing force equations first because they're easier than the moment equations. But, so I would put force before moment. However, what other equation? Gracie, what equations would I want to do first? It may be a moment equation.
A moment equation? I don't know.
Yeah, but why? How would you go to select which equation to do, to choose?
One with the least amount of unknowns.
The one with the least amount of variables, or really, what do we really want to do? The one that only has one unknown in the equation, right? Right? So we want to choose an equation that only has one unknown in it. Everybody with me? Yeah? Which equation we're going to choose?
Sum of forces in the x.
Okay, this one that has the least, that has one unknown. So let's see. What do we want to do? Let's go, keep going. Matt, H,
I'm gonna go with the sum of the forces in the x,
how come?
because there's only the one reaction in the x.
Great. So sum of the forces in the x gets you to be ax is equal to 0. Then what do you want to do? Who wants to pose a question? Ethan, equation next. Say it again.
Some of that is y.
Great. Sum of the forces in the y equals ay plus 200 equals 0, and ay equals negative 200. Make sure you write the units. That's another thing that people leave out a lot, the units. Okay, so I had somebody ask me a question recently. If I drew ay in the positive and I got a negative, do I have to go back and redraw the direction of that force? No. Did everybody get that? When someone looks at the solution here, they are looking at how you drew AX and they're looking at the value. And the person knows that since I got a negative, it's actually going in the other direction. So your solution is both the free body diagram and the answer. Oops. So you want to make sure that you leave it as is. You set up your free body diagram showing directions, you calculated the math, and you have a negative, and you leave it like that. Charlie?
What if you did do that? If you changed the arrow the other way?
Then you really screwed it up. Then what you have to do is you have to redo the problem, right? Do we want to go there?
No.
No, I don't want anybody to even think that they have to do anything beyond that.
I'll remember now.
Yeah, I know. Yeah. Okay, what's the next question, equation? Malcolm?
Some of the forces in the z.
Some of the forces in the z, and now the reason why I picked this quiz is this one. I want to make sure that you don't make this error on the exam, because probably some people will make the error today on the quiz. When you do the moment equation, sum of the moment, where did you decide to do your sum of moments about? So sum of the moments about A, did you just do it about A, or did you do it about the x-axis going through A? I did the axis. Sum of the moments about the x-axis. So, sum of the moment about the x-axis. What do you put on there? You have to put the moment, this moment, it's a concentrated moment. Remember, it's like a screwdriver spinning it there. You have to put the moment that's in the x here, even though the line that you're finding your moment about goes through that point. What else creates a moment about the x-axis? The 200 times what's the distance?
2.5.
Okay.
It should be 2.
2.
Okay, so let's look at this.
Oh, is that
You're
what?
trying to find the moment about the x-axis. 200 is going what? In the y. The perpendicular distance has to be in the z. What is it? 2. Does it create a positive or negative?
Positive.
Positive. And then does the 150 create a moment about x?
Indeed.
150 times
2.
2. The 150 is in the z. You're trying to find the moment about the x. The distance has got to be in the y. Positive or negative?
Negative.
Negative. So equals 0. So in the end, the moment about x is equal to 300 minus 400, and it comes out to be negative 100, what is it, Newton meter. Okay, make sure, everybody's listening, make sure that you put this inside the equation, because otherwise you will get the wrong sign from your moment. Good? Okay, so we're done. Then you would do it for the other axes too. Okay. So